Yes, afternoon, learners. Are you guys hearing me? Afternoon, afternoon. Are you guys hearing me? I can't get any response. Okay, great.
Yes.
All right. Compliments for the new year. Compliments for the new year to everyone.
Likewise, sir.
All right. So I hope you have enjoyed your Christmas Eve and basically the New Year. So compliments for that. We are to start with our lesson for today. I believe everyone is ready. The topics were communicated, and I do believe we have gone through our notes. And all I would ask from your side is to ensure that you have a calculator on your side. You basically have a book, a notebook whereby you are writing. So I would like to remind you to use your school name that we actually know. I can see iPhone there. I'm not sure who is that, but ensure that you have changed your names or basically the nicknames to the school names that we know you. Okay, so do that. So I advise you to find a calculator and perhaps if you do have a ruler, it's also fine. Maybe some of you have some hard copy papers whereby you would like to have a look at your own personal questions that you have for linear programming, just with a guidance from my side, and then you can apply on what you have on the resources you as well have on your side. Okay, so yes, we are back again. We are basically back again. So let's just bow down our heads and pray. Ne? You guys are hearing me, right?
Yes, sir.
All right, great. I'm not sure if the response is delayed or you guys are just slow in answering me, but I can hear you very well as well. Okay, let's pray. Heavenly Father, we thank you for this wonderful day. We thank you for this wonderful year, a wonderful week. Be with us throughout our teaching time. Be with our learners as they prepare for their final examinations to be written this month. Guide them, give them the spirit of calmness, the spirit of remembering, and always be on their sides. Be with our parents as they prepare the learners for school and final examinations. In Jesus' name we pray. Amen.
Amen.
All right. You guys, you are hearing me, right?
Yes, sir.
Okay, good. Now I can see that the response is actually fine. Okay. Just a recap on what you have done previously on vectors. There will be a question that you are going to do face to face when we meet. And just a recap on that. So the other question or a question you had on vectors, we will have a look at that on face-to-face. And I have just prepared for you 1 to 2 questions based on vectors. So we will have to look at that. From there, we will then look at transformation. We will look at transformation. It is a topic that is highly practical. One really has to be involved. And I believe we'll also have a look at it on face-to-face when we meet again, because of some other components that may not be appropriate for online. And therefore, we will have a look at that as well. And we will be concluding with linear programming. It is a topic that a number of learners find it to be challenging, but it's very, very nice and interesting. So it is quite easy. Just require you to basically concentrate and focus. All right. Yes, a recap on vectors, okay? A recap on vectors. And this is what they are likely to bring in the exam. So it's just a type of question I have made for you from this side. All right, so it says that OPQR is a rectangle and O is the origin. M is the midpoint of RQ, and PT to TQ is actually equals 2 to 1. There is something here which is missing. I believe you cannot see it. It's actually 2 to 1, okay? OP is basically P and OR is actually R. I will remind you again. Basically, I will remind you again on vectors. You have done this, that vectors, what are the characteristics of vectors, or what are the properties of vectors? I am, or you are aware that a vector has both magnitude and direction. You should be able to know that. Both magnitude and direction. Only then we can call that a vector, okay? So it says find in terms of P and or R in its simplest form. You guys, you are hearing me, right?
Yes,
Yes,
sir.
sir. Yes,
Right,
sir.
great. Great, okay. So remember, they are saying this vector is coming from what? It's coming from M, going where? Going to Q, okay? The arrow there on top is very important because the vector has what? Has magnitude, okay? MQ, how long is MQ? How long is this, okay? And then it has also a direction. Direction is where is it going? It means it's starting from where? From M and then ending at Q. So that is basically it. All you need to know is the properties of a vector, and then you have gotten it. Okay, so MQ, okay, vector MQ. So we are actually starting from M, ne? We are actually starting from M, and they are saying that OP, okay, when you are coming from O going to P, the vector there is basically what is just P. But if you are going this direction, it will be what?
Negative.
Negative. Yes. PO is going to be negative. Okay. PO is going to be negative P. But because OP is actually P, okay? Same applies to OR when you are going that direction. Okay. OR is actually R. But when you say RO, is going to be what? Is going to be negative R. So there will be change in basically a direction there, okay? So that one you are fine with it, okay? And therefore, MQ is going to be what? Who is going to tell us that? Because it's just a recap on what you have done the previous days. Is going to be what? All right, great. I'll do it for you, okay? Remember this, it says that PT, okay? They are saying PT is basically that and TQ is actually this one, okay? That one was not there. And again, OP is P and OR is R. I want you to know this. M is the midpoint of RQ. This is where our focus should be, okay? They are saying M is the midpoint of RQ, okay? So what is MQ? What is MQ? Now I want you to know this, a midpoint is just half of the line, okay? A midpoint is
So
just
it's
half
half
of the
P.
line. That is correct.
So
That is
yeah.
correct, okay? That is correct. Very, very good on that, okay? So remember, this OP and RQ are what? Are parallel. Okay, so therefore RP is also what? I mean RQ is also P. Can you see that? But they are saying that now M is actually what? Is the midpoint. Is the midpoint of what? Is the midpoint of RQ. Is the midpoint, okay? So if you are having RQ from here to there is M there. So it means that the distance here to there is actually the same, okay? And you know the distance basically here, the whole distance is just P. Therefore, what is this? What is that? It's just going to be half what? It's just going to be half P, okay? So that one is just half P. Who is not fine with that one? Okay, great. All right, sure. Now MT, who can tell us the values or the vectors of MT?
Okay.
It is a recap. You should be able to answer now. MT, okay? Coming from M, going to T, okay? So they want this vector MT. They want this vector MT. Okay, so this is the vector they want. What is that vector?
Half of P plus 1/3.
Plus 1/3.
Yes, sir.
Okay, if it was 2 marks, I'll give you 1 mark. You will definitely get score a mark there. Okay, try again. You are almost there. Okay, that half of P is correct. Plus 1/3 of what?
T and Q is 1, sir. It says in
Plus,
the
no,
ratio.
plus 1/3 R.
Okay.
Okay,
Oh,
okay, no, I want somebody to tell me again. Okay, it's half P plus 1/3 what?
R.
Plus 1/3 what? That is it, negative. Remember R is going like this. But now you have to go like this and then you go like that. Can you see that? Yes, okay. So you guys,
Okay.
you should not neglect those simple things. It looks simple, but you really need to bear in mind the direction of the vector is very important. Therefore, we know that MT is going to be what? Is going to be Q, vector MQ plus vector QT, okay? And what is this? What is your MQ? You know your MQ is just what? Is just half of what? Half of P, okay? And then you basically know that your QT, vector QT. Okay, vector QT is going to be what? Is going to be 1/3, negative 1/3 of R. Ne? Why is it 1/3? Because they are saying PT, okay? PT is what? PT is 2, remember, is actually what? 2, and then TQ is what? TQ is actually 1. So you need to find the ratio total, which is 3, okay? Therefore, from here, P T is going to be what? Is going to be 2 over 3 what? R. Only when you are going like that, okay? But if you are going to down, it's going to be negative 2 over 3 R, okay? And then TQ is going to be what? Is going to be 1/3 R only when you are going up. But if you are going down, it's going to be negative 1/3 R, okay? Therefore, this one is going to be half P minus what? 1/3 R. But I know you guys are getting it. You just need to clear out the small things, okay? Great. Yes, we still have one more, okay? So OT. Okay, OT. OT.
Sam,
Yes.
I got P plus 2 over 3 R.
That is correct. Is it Kakwere?
Yes, Sam.
Great. That is actually correct. Okay. Remember the components, the properties. All you need is to know the properties. When it comes to vectors, just know the properties. That is all. It says a vector has both what? Magnitude and direction. Direction is very, very important. Okay. Direction is very, very important. So you know that OT, for you to get OT, you can get there through various channels, but the shortest way is actually this. Okay, you can go like this, and like that, but it's too long. Okay, in the end, everything will be the same, but it's actually too long. Okay, so we prefer this direction. Okay, so I prefer going like that. You know that this is P, and this PT is what? Is just 2 over 3, 2/3 of what? Of R. Therefore, vector OT is going to be vector OP plus PT, okay, vector PT. And what is OP? OP is just P, and then what is PT? PT is basically 2/3 of R. Okay.
Yeah.
You are, yes. So just bear in mind the direction, okay? But if they say vector TO, now you are coming from T going to O. Remember direction, you are going to change direction, okay? All you need is to know how big is that vector. That vector is P, but the direction is going to be what? Is going to be maybe negative P. You don't know that, or maybe P. You need to know, because they are going to provide you with all necessary and sufficient information. All you need is to bear in mind the size and direction. Are we together? Okay.
Yes, sir.
So yes, if it's TP is going to be now negative 2/3 of R, and then plus PO is no longer going to be P, but is going to be minus what? Minus P, isn't?
Yes, sir.
Yes, great. All right. So the last one on vectors is basically that is very nice, and I want you guys to know it. There was a similar question in your final exam that you have written. All you need to understand, just read with understanding. They are saying that vector MT is actually what? Is 2K and negative K. What is this, class? Somebody to tell me, what is that?
It's the magnitude.
Is the magnitude. That is the magnitude. And they are saying the magnitude of what? Of MT is actually what? Is that. All you need is to find the magnitude of what? All you need to find is the magnitude of this MT, and you equate it to that, because definitely it's going to be equal to that. Okay, that is all you need to do. Are we together?
Yes, sir.
Yes,
sir.
okay. Because they are saying that they are saying that the magnitude of vector MT is actually what? Is the square root of 180. Now, what is you need to find this in terms of the given information, okay? So the magnitude has a formula. That is basically what you just is the square root of the squared components. Are we together? So that is
Yes.
going to be what? Is going to be the square root of
X squared.
2k
Multiplied.
squared plus what? Plus again negative k
Squared.
squared. Yes, it's going to be that, which is equal to what? They are saying is going to be equal to that when you work it out. K is going to be equal to 180. And then you basically work out what you have under the square root. What are you having? So you are going to square what? You will have a square root there. So remember this law. The law, this is now algebra, okay? If you are having a, b raised to n is exactly the same thing as a to n, b raised to n, eh? So you need to use that. So 2 raised to power 2 is what? Is going to be 4. Again, k raised to power 2 is going to be what? Is going to be k squared plus, yes. Now what is going to be that? Is going, yes, it's just going to be k squared, okay? It's not going to be minus k because it's actually inside the bracket, ne? So it's like negative k multiplying what? Multiplying again negative, yes, negative k. So this negative and negative cancel out and you only have k squared, okay? So equals square root of 180. Our aim is to find what? The value of k. That is basically our aim, to find the value of k, okay? So k is under the square root again. What are you going to do?
We
Even
get rid of
before
this.
that, yes, you get rid of the square. But if you want, you can simplify this because you can see these are like terms, isn't?
Yes, sir.
Yes, they are like terms. So you can say, oh, 4k squared plus k squared is going to be what?
5k squared.
5k.
That is correct. That is correct. It's going to be 5k squared equals what? Equals square root of 180. Okay. Now, what removes a square root?
A square.
It's a square. And what removes a square?
A square root.
The square root. All you need is to know those basic components. Okay. So you are going to apply a power 2 there. What you do on this side, you also do it on the other side, isn't?
Yes, sir.
This cancels with it, and again, this cancels with it because all of them are having what? They are all having square root, isn't?
Yes, sir.
Yes, okay. And then therefore you are having what? You are now remaining with 5k squared equals what? 180. Yes, 180. What are you going to do next?
Divide both by 5.
That is correct. You are going to divide everything by 5. You divide everything by 5. This cancel out. Your k squared is equal to what? I said we should have our calculators. I believe 36. Yes, correct. Okay. Remember they are saying find what? Find k. Do we have our k?
No.
Yes, you are going to do what? You are going to apply a square root. You are going to apply a square root there, okay? And also a square root there. But on this side, you will say what? You are going to say plus or minus. You are going to say plus or minus there, okay? Therefore, our k is going to be what? This will cancel out. Our k is going to be plus minus what?
6.
Plus minus 6, okay? Therefore, in this case, your k can be negative, your k can be positive. Are we together?
Yes.
Okay, you can take all of them because when you substitute here and square, even if it's negative or positive, the result will always be positive. It doesn't matter. So here, it's just going to be plus or minus 6. Okay. Yes, great. So basically, that's it. You should not Maybe you guys want to take a screenshot before I erase. But this
Yes, please.
the lesson is available on YouTube. It is also available on the Facebook page and all social medias of PEN if you want to go through again later on. All right.
Thank you, sir.
Welcome. Okay. So, all right. Yes. Is there anyone with a question?
It's me, sir. So I wanted to ask. The question said find the positive value of k. So it doesn't really matter if I write next plus
Okay.
minus
You're
plus
welcome.
minus 6.
Yes. The positive value of k is basically 6. Okay. Thank you for that. I apologize. I have not even looked at that very well. I just looked at the sense that definitely all k's will work out. Okay. But if it's the positive k, definitely the positive k is what? It's just 6, isn't it?
Yes, sir.
Yes, sir.
Yes. Okay. So it's just going to be 6. Thank you very much for that. Okay. But you should know that sense that is going to work out. All are possible solutions, -6 and also 6. Okay. That is just now beyond critical thinking. All right. We are now moving to transformation before we look at linear programming. Okay. So on transformation, it's a very, very easy topic, although we neglect it, but it is quite very, very easy. Okay. Yes. Is there anybody with a question?
So I have a question with what is this vector?
Okay.
There was a question we were given Saturday, Friday.
Yes.
It says that the line OP is extended to C such that can I set it on the group then so we'll check?
Okay. No, I think maybe it's the question that I just received, but yeah, you can send it on the group. Just send it to me directly.
I don't have your number, sir.
Okay. I'll follow up. But I'm on the group. Just check there on the group there. I think you can see me there. Okay, but I will still follow up on you. Ne? I saw that question, and it is maybe the question I said we are going to do it when we opened. Actually, our first. Is it not that one?
It's not the hard one, sir. The hard one would be the other,
I don't.
the other one.
Okay, I don't know now the hard one, but I can say if you cannot find my number, then just send it on the group. Okay. Are we together? Okay, if you cannot find my number, just send it on the group, then I can get it from there because now it needs to be drawn and everything. All right, great. Okay, so transformation, we are going to focus on basically 4 types of transformation. You need to know them. Okay, so you need to know the types of transformation. Number 1 is reflection. Okay, reflection. That is basically number 1. Now I want to write something for you here, and you should be able to know it. On this topic of transformation, you are only going to be asked 2 things, only 2 questions that will come in the exam. Number 1, to draw. Number 2, to describe. Only 2 questions. That is all on this topic, only 2. Number 1 is either you draw the transformation that reflect that figure what, or rotate that figure what, that is now drawing, or they will say describe fully the single transformation. That is only 2 questions that are coming, and I want you to know all the components that you need to describe per transformation. Okay, drawing is fine, but I want you now, what I'm going to add here, when you are basically describing a transformation, which is reflection, you, number 1, you state the name of the transformation. That is always number 1 when you are describing. Okay, that you will say it is reflection And then for reflection, you give what? You give the line of reflection, okay? So sometimes they say the mirror line, the equation, okay? So, all right, I have sorted that one out. Okay, so you state that it's a reflection. That is now the name of the transformation. And the second thing that you are going to state is actually what? The mirror line or the equation, okay? The line of what? The line of reflection, okay? This could be an equation in the form of an equation or just a number or whatsoever, okay? So that's it. For reflection, it just comes with 2 marks. When you are describing, you will say is reflection maybe in the line of y-axis, x-axis, or in the line of y equals 2, x equals 3, something like that. Are we together? Great.
Yes, sir.
Then number two is rotation. Yes?
To discuss, basically, take the last 3 digits of your number. I don't.
Come again?
Please take the last 3 digits of that number.
Okay, so it's 2305992. It should be 992.
Okay.
2305992. All right, great. Okay, so for rotation, you are actually for rotation, you will basically describe it by giving 3 components. Okay, so of which the first one, when you are describing the transformation, you state the transformation that you see. If it looks like, if the figures you see, they look like something is rotated, then you say that is rotation. Okay, then the second thing that you are going to state is what? The center of rotation. The center of rotation. Okay, and lastly, you are going to give the angle of rotation. Sometimes we will say is 90-degree clockwise, maybe 90-degree anti-clockwise, or 45 degrees whatsoever. Okay, so this one is just the angle of rotation. It comes with 3 marks always when you are describing. So you need to say that, oh, is rotation, you get a mark for that. Then you give the sender, oh, that is rotated at the center. The center is just coordinate. Maybe it's the 0, 0 or 2, 0, or maybe 3, -1, something like that. Okay. And then the angle, you say, oh, it's just rotated 90-degree clockwise or whatsoever anti-clockwise. You get all your 3 marks. Okay. And then the third one is basically
if you mention clockwise, I 90 degrees, I not speak like
come again.
Clockwise.
Come
so
again.
If you mention the, I'm saying if you mention the degrees, that not already state in which direction, whether it's clockwise or anti-clockwise.
You need to negate it. No, necessarily not. Okay, necessarily not. We will look at that. Okay, we will look at that when we go into the topic itself. I will give you the direction from there. Okay, so if it should be negative, if it's what? Who wants to tell us?
If it's anti-clockwise,
It should be negative. And if it's basically clockwise, it's going to be what? Yes.
positive.
So we are going to look at all those things there. I'm just giving now everything that you need to know. But it does not mean when you give that is 90-degree, it is clockwise or anti-clockwise. No. Okay. So you always need to state the direction, the angle and direction. Okay. All right. So the third one is actually enlargement. The third one is basically enlargement. enlargement. You also give 3 components on it. If the figures are basically enlarged, you are going to give about 3 components. Number 1, you should be able to state the transformation, that is what is enlargement. And then the second one, you state the scale factor. They actually say the SF, the scale factor of what? Of enlargement, scale factor of enlargement. Okay, sometimes you can see that, oh, what if I'm having something like this, and then the other maybe object or is going to be this. Now it's having what? It's having 6 blocks, but this is the original, this is the object, and this is the image. So what is the scale factor? Okay, we are also going to look at it when you find to, in order for one to find the scale factor. So we basically as well look at it. So you can see that this one is multiplied by what? Is multiplied by 3 in order for you to get 6. So the scale factor is 3. Okay, that is just, you say, oh, it's enlargement, the scale factor is 3, and also you basically give what? The center of enlargement. Okay, you also give the center of enlargement. So that is basically the last thing. You give the center of enlargement. That is actually it. And the last one is basically translation. Very nice. You should be able to know translation because you have done vectors already. Okay, so on translation, what do you give? You give 2 things. Okay, so when you look at this, comes with 3 marks. But now when it comes to translation, only comes with 2 marks. You just say it is translation. And then you, for translation, you basically give what? The vector of translation. Okay, so you give the vector of translation. Okay, so it is 2 marks. When you know these things, even if you go in the exam, when they say describe, you should be able to fully describe. If it's a reflection, you should give 2 points. If it's a rotation, 3 points. And if it is actually enlargement, you should be able to give about 3 points, not just about, but just 3 points. And for translation, you should have a look and provide 2 information. Are we together? Okay, I want you guys to take a screenshot of that as well because it's very, very important. You have 5 seconds. Great. Okay. All right. Here we are. It is an exam type of question. It says, describe fully the single transformation that maps triangle S onto what? Onto triangle T. Okay. So triangle S onto triangle T. What is that transformation? You can already see that there are 3 marks, and 3 marks only applies to what? 3 marks only applies to enlargement and rotation. Are we together?
Yes,
Yes.
Okay, so it only applies to that. So it's just one of those tools. For enlargement, it means something was small and it's made bigger. Rotation, the image and object are the same in size, but basically the direction has changed because you need to give what? You need to give the direction, the angle and direction that is clockwise or anti-clockwise. Okay, so now when you look at that, is what? The name, number 1, you should always start with the name of the transformation. What is the name?
enlargement.
Okay, so is enlargement, yes. And then number 2, what do you give again for enlargement?
Scale factor, sir.
Factor.
The scale factor. How do you find the scale factor? Is what?
2, sir.
This a side,
2, sir.
okay, is a side of what? Of the image, ne? A side of the image, okay, divided by what? By the side of the object, okay? So it is a side of the image divided by the side of the object. So you look at this, is actually the image, and this is the object. The object is the original one. So if we take the corresponding sides of what? Of the image, these are the two corresponding ones. So basically our scale factor is going to be what? Our scale factor is going to be, you count now, this is 1, 2, 3, 4. So our scale factor is going to be what? That one is 4 divided by what? The image divided by what? By the object, 1, 2, divided by 2. And then you get what?
2, sir.
You get 2. Therefore, our scale factor is 2. Another corresponding side you may take is this, okay? As long as you are taking corresponding sides. So this correspond with that one, okay? So this is actually what? This is the image, and this is the object, okay? So you are again going to say what? Oh, from here is 1, 2. That one there is 2. And then here is just what? You just have 1 there. So divided by 1, it will still give you what? It will still give you 2, okay? It doesn't matter. Okay, and then the next thing you have to provide for enlargement is the center of enlargement. I'm going now to teach you. Remember, this is no longer teaching, it's like tutoring things, because I have taught you already. I have taught you already these things, we have repeated them, so we as well want to meet time. Are we together?
Yes, sir.
Yes, sir.
My apology, I just realized that we have new students that I have not seen and that they have not seen me as we are online. I am basically Master Katemo Dominicus, okay? So I am Master Katemo, or basically Dominicus, for those that just joined us this year. All right. Now, the next thing is finding the center of enlargement, okay? You are finding the center of enlargement. How do you find the center of enlargement? You take your ruler. This one, for enlargement, you are using your ruler. We will go back to rotation there. But for enlargement, you use your ruler. Are we together? And then you find 2 corresponding sides, okay? So this correspond with what? With this on the image, okay? The object here correspond with this on the what? On the image, ne? And then you take your ruler and extend the line as far as long as possible. Are we together? Okay, you take a ruler and you extend. It's going to be a little bit of challenge on my side because of it's the screen, but I'll try my best. Okay, so you are going to extend that line as long as it's going to pass through those points like that. Okay, but as I have said, you should have a ruler, ne? You should have a ruler. If it's going to be a paper, you will nicely see it. For enlargement, you have to take at least 2 points, okay? 2 points that are corresponding, one on the image, one on the object, okay? The next one, this correspond with which one? This correspond with which one? This one here, okay? So they correspond. Those ones actually correspond, and then you take your ruler, you join those 2 points, okay? You join with a ruler, not with your yes. There is a question from Rosta. Yes.
Yes, about the scale factor. Isn't the scale factor supposed to be 1/2? Because isn't the image triangle T? Because it said the question says it maps triangle S onto T. So isn't T the image?
Basically, S
So it's smaller,
S
meaning
no
perfect S.
S no S is the image. Okay, S is the image. Okay, so it's fine. I received the same question when I taught you those days again. S is going to be the image, but remember what we are going to. Okay, remember what you are going to be provided in the exam. Just a minute, ne? Are we together? Just a minute. Looking for something. Great. Okay. I was actually looking for my ruler on this side. Okay. Yeah. So I have gotten a ruler now, and I'm trying to find, yes. So are you guys seeing that?
Yes, sir.
Okay. So yeah, I'm trying to make it at least a little bit or more of accurate. Okay. It is a soft ruler, so it requires some patency. Right. Right, great. Right, that one we have it. Can you see that it's actually nice? Are you guys seeing that one?
Yes, sir.
Yes, sir.
Yes, sir.
Great. Yes. So another one that I want to take is right here, so that we at least have something better. Okay. Great, great. So we can already see the center of, now we are nicely seeing the center of enlargement from that, okay? We are seeing now the center of enlargement from that. Rosta, if I may just come back to you again, that S is actually what? Is actually the object, but what you are going to get in the exam is something that differentiates between the image and the object. Okay, so it's something that differentiates. I have given you all alternative. So there is this. Can you see when you look at this and this one right here, which one is the image and which one is the object? The one in
Sir, but aren't they congruent?
no, that one is fine. Congruency, it's okay. Remember, if you are having A, okay, let me choose another color, A and this A. This one is always the object. And this is actually what is always the image. That's why what you receive in the exam, you always receive triangles labeled like that. Okay, labeled A prime, A prime prime. Okay, when you look at this, all right, so the person whose name is iPhone, I think is can you guys check your usernames?
It's me, sir.
Okay, Kenneth, can you see on the screen now? It's Mauritius, I believe.
Yes, sir.
Right? iPhone. Yeah, it's Mauritius.
Yes, sir.
All right. So, Kenneth, can you see the writings on my? All right. Okay, great. Okay, great. So in the end, in the exam, in the final exam, you are going to see these two things, of which whatever you see, they will have triangle. They will have a triangle like this. This is A, B, C, and then they will have another triangle like this, of which they are having what? They will have A prime, B prime, C prime like that. This triangle, the first one, is always what? Is always the object, okay? And the second one definitely is going to be what? Is going to be the image. All right. So the scale, we have gotten our center. We have gotten our center of what? Our center of enlargement. Remember, the center of enlargement is going to be some coordinates, okay? The center of enlargement is going to be some coordinates. And then your center there is just going to be what? Is going to be 0, 0, okay? So we have fully described that. Okay, it is actually enlargement, and the scale factor is 2, and the center of enlargement is 0, 0, okay? So that one is fully
Yeah, I have a question.
described. Yes.
So you know now, for that, how would you know your center is 0, 0? Let's say, for instance, if you took the corresponding point as the red line, the,
No,
towards the
it's
bottom,
going to be okay, Mauritius. It's fine. I have gotten your question. Eh? The center will always be where the lines are meeting. That is how you will know the center. Okay, it's where the lines are meeting.
what I'm trying to say, you see the point at coordinate 2, 1, eh?
At coordinate 2, 1 here.
And then 4, 2.
Again at 4, 2 here, yes.
And 8, 8, 4.
And what? 8,
8,
4.
4.
Okay, yeah.
So those are two, what is it?
2 points.
Yes. And the
Yes.
lines, and they both at 4, 2.
That one, I like your question. Okay, remember now that one,
Sir,
that
can you
line
please
is going.
repeat this question? Because I
Okay,
can't.
okay. Yes, his line is a little bit cracking. I'm working hard to hearing him also on this side. But what I can tell you, if you are choosing this point and this one, and then you join with a ruler, and again you choose, you know, this one here, this point corresponds, okay? This point again, this point here, okay, this one here correspond with which one? This one here again. And you know that is the second one, and again. There's no way those lines are going to meet because they are repeated lines. Are we together? Therefore, you are only going to
Yes, sir.
use one of them, and you use this one again. Remember, you need at least 2 of them. Okay, 2 are enough. So you cannot use those 2. Are we together? Those ones, they will never give you, they will never meet. They will never meet because they are actually what? They are actually in the same, exactly same line. Okay, are we together with that?
Yes, sir.
Right, great. Okay, so I want you guys to take a screenshot of that. It's going to be your take home, because it's based on enlargement. Do take a screenshot of it. 1, 2, 3, 4, 5. Okay, everyone is done. Great. Okay, now describe fully the single transformation which maps triangle A onto triangle B. Okay, which maps triangle A onto triangle B. What is that going to be?
Sir, rotation.
Rotation.
Okay, it is going to be a rotation.
So isn't a rotation normally 3 marks?
Yeah, actually, but depending on what they want, so sometimes they can cut the marks. But yeah, it's not just that when you see something which is 3 marks, or I mean 2 marks, is always maybe reflection, or basically rotation or whatsoever. I want you guys to have a look at that. Very, very nice. Okay, so I have given you what you need to know per transformation, and also mark allocations also to know it. But one thing you need to look at figures from different angles, not just that when you see it first that no, it is rotation, or it is enlargement, or it is a reflection. You need to see it nicely, so that you do not just conclude that no, this is actually rotation. But how sure are you that that is actually rotation? Do you have enough evidence to prove that? So you need to look at that. On the other side, marks, they always they give us an idea that it might not be this, or it might be this. So what is okay, it's that is actually what you are saying it is.
Rotation, sir.
Okay, it is rotation. Anybody else having a different answer from that?
So I almost assumed it was translation, but it is rotation.
It is not translation, because for translation, the direction is the same, the image is the same as object.
Okay, sir.
Okay. Yeah, we want to go a little bit fast. We do not want to go back to theories and so forth, because we have done these things, but we can go back when there is really a need. Okay, guys, that is not rotation.
Why not?
That is
So
not
I'm
rotation.
correct.
Yes, you are not correct. You say translation. It is a reflection.
Oh, I see.
Remember, it
Now,
is
sir.
reflection. All you need is to know in which line is it reflected.
There it is.
I
So it
like
runs
it when I'm
zero.
yes, exactly. But the not zero. I'm just seeing what I'm just now. I'm analyzing your feedback. But what you can see now is there is reflected in the line of y equals x. Is reflected here. You know, if you take your calculator and put the calculator upside down, you look in the screen, you can see that it is actually reflected from there, because the distance from here to there is the same again as from there to there. Okay, and then when you look at this again, when you look at this, is forming exactly something the same. It's an M. It means it's equal. This EL is exactly the same. Or even if you are going like this and then you go like that, the distance is the same. Are we together?
Yes, sir. No, sir.
Okay.
We're in this
Yes.
situation where we can't really identify whether it's a reflection or rotation, sir. Then what should we really like do, or what trick is there to do to really?
No, all I have told you is that. All I told you, remember when I'm not sure now if it's you or the kids I teach from the other side of school, but all I have said is that try by all means to make use of your what? To make use of your calculator screen to see, because your calculator screen, if you put your calculator screen upside down in this line and then you try to see, you always see the object and the image. You always see the image, how it looks like. Okay, so that's why I have said that some of these things we need to be in class, so that I demonstrate, so that I show you all these techniques. It's like when you are finding the center of rotation, one needs a compass, of which it's not a good tool for online. Are we together? Okay.
Yes,
So
sir.
all you need, yes, all you need is to nicely think. Okay. You should not be limited at all. That's why I've said you should not really look at it as it's a rotation. Okay. So not always like that. And this one is also telling us that it should be. So it is a rotation. It is a
Reflex.
rotation in the line of y equals what? Y equals x. Because when y is 1, x is also 1. They are equal. When y is 2, x is also what? 2. Okay. And when also y is 7, the drawing now should pass there. It is actually the same thing. So that is actually it. Okay. Yes, describing, we have looked at that. I would like us actually to look at rotation. I would like us to look at rotation. So it is as well not a challenge, but all I'm telling you is that do not be, all you should be able to do is that see and look at the figure very well. Okay, so you see it's 2 marks, and then you might just say, oh, it is actually rotation or enlargement. You should have sufficient information. You should be able to have enough evidence of that. Okay, so that's basically it. There is another figure there. Who can describe that figure for us?
Say it's translation.
Translation.
Great, great. I like it. I like it. Actually, it's also a recap because we have done this. We have done this topic so many times as well. I like it. Why is it translation?
Because it moved. It didn't. Wow. Okay.
Okay. Why is it translation?
They're the same size.
Say it
The
moved.
size is actually this.
It moved position in this case.
Okay. Translation. Remember, for translation, the size of the object is the same and the direction is the same. Wherever the objects and the image are facing, they are the same. So it is, I'm confident that it is translation. Okay, so it is translation. And when you are describing the transformation, what do you look at? Okay, so it's going to be,
So,
yes.
It's a vector.
can you please go back to the previous question?
To the previous, you want me to go back to the previous question?
Yes, sir.
Okay. Yes.
I did not say that that was reflection.
Yes, it is. Oh,
That's a
right here.
rotation.
Yes, yes, I have seen it right here. So it is actually a reflection from that side. Thank you once again on that. Okay. Yes, I believe there was a person who wanted to ask something from this side.
It's
Is
fine,
it
sir.
Swain or?
Yes,
It's
sir, it's
fine.
fine. Yes,
Okay, all right, sure. Okay. Sorry for that. Just a minute.
Yes, sir.
Just a minute, right? All right, sorry for that. Tech was actually killing me on this side. But we actually managed to sort it out, okay? Sorry for that. All right, yes. What else do you need to give when you're basically describing the single transformation of translation? Yes, now, yes, the vector, but remember you as well have to find it. Okay, that is now
So
what I
direction.
want. Yes, in terms of a vector, how are you going to give that? Okay, so I'll do this one for you. How do you find, remember you have done vectors. We have done vectors and also you have been doing vectors with now, say on this side, okay? So how do you find the vector of translation, okay? So because they are saying that shape D onto what? Shape D onto shape shape E, okay? So we are coming from where basically we are looking at D and then moving to E. All right. So all you need is to connect 2 points. Okay. Corresponding points. That points correspond with which one? With this. Now go there by means of vectors. Vectors have what? Both magnitude and direction. And a vector is in the form of X and Y. The X components up and the Y components down, okay? How do I get there? So if you are going like this, your X, if you are going up, it will be what? It will be, now Y will be 1, 2, 3. You cannot go any more beyond that because it's in the line with this point already. So you have your Y to be what? To be 3. It's positive 3 because you are going up. You are going up there. Okay. And then you have to go until you reach this point. So you move. Now this is the X. Okay. So 1, 2, 3, 4, 5, 6. Therefore, your X is what? Your X is 6. Okay. But what if, remember, this is where we are going, right? Okay. We are coming from D going there. What if you want to go like this? What if you want to go like this and then like this? So what if you want to go like that? Then your X will be 1, 2, 3, 4, 5, 6. It's still going to be 6. Okay. And then your Y is going to be what? It's going to be 1, 2, 3. It will still be what? It will still be 3. It doesn't matter. As long as vectors have both what? Magnitude and direction. So we should be able to know where we are going, if it's positive or negative. Okay. So it should not be a challenge with that one. Okay. That should not be basically a challenge. Is everybody fine with it?
Yes, sir.
Yes, sir.
Okay. So
Yes, sir.
all right, great. Okay. Same applies when you are translating. Same applies when you are translating a figure. All you need is to apply the vectors of translation, because when you are basically translating a figure, they are going to give you the vector of translation. For example, when they've given you this, they say that translate the triangle shown below by that. Whatever you see here is actually what is your vector of translation. That is actually your vector of translation. All you need when you are now drawing, remember, on transformation, you are actually going to do what? You will be able to draw and describe. You will be able to draw and describe, okay? Now, when you look at it, they say translate the triangle shown below by 8. It means your X, you are going to move 8 steps on the X axis and 2 steps on the Y axis, but you are going down because it's negative. So if I'm translating this point here, on the x, if I'm going like that, I'll go 8 times. Are we together? Because it's positive, I have to go like that on the x, because our 8 here is actually what? It's actually positive. Okay, so that one you need to bear in mind that. Okay, so I have to move 8 steps, so it will be 1, 2, 3, 4, 5, 6, 7, 8. That's actually it. I have to stop there, and then I'll have to move down 2 steps. I have to move down 2 steps because it's negative. Okay, so that one is negative. I'll have to move down 2 steps, and it will be 1, 2. Okay, it means the point will be based here. That point will be there. Okay, so I take another one, and then I translate it. It doesn't matter where you go, if you are going down first or you are going up first, it does not matter at all. Okay, so I go on this side. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have moved 8 steps on the positive numbers of the x-axis. Okay, and then the next thing is to move 2 steps down, because it's negative. If it was positive, I'll have to move up. So therefore, I'll have to move down again some 3 steps there. So this one will be, 2, 1, 2. That point will be based right here. I take the last one. The last one, you can guess it even because it's the last. I think it's going to be there, but we do not want to guess. We want to live by evidence. Okay, so by evidence and by proof, you move again 8 steps from there. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. You end there. You need to move down again some 2 steps. Okay, so it's going to be 1, 2. So that point is exactly going to be where? Is exactly going to be right here. And then you now take your ruler and you join. So this one is going to be what? Is going to be the image after translation. It does not matter at all. Are we together?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So basically, it doesn't matter. The other one is actually that's why I say that you are not limited to where you should go up or down. No, that does not matter at all. The other thing is that if you want to go down first, it's fine. What if I'm choosing this point but I go down? I have to go down 2 steps because it's negative. So it will be -1, -2. Then the next thing, I have to go on the x-axis by 8 steps. Okay, so this one will be 1, 2, 3, 4, 5, 6, 7, 8. This point is the same point there. So you always get it. It's the same point exactly when you are going like this, and actually when you are going like that. So basically, it's actually the same thing there. So it should not be a challenge for that. Okay. All right. Are we fine with that?
Yes,
Yes.
sir.
All right, great. Okay. So we are yet to move. There is that one. I want you to take a screenshot of that. You should be able to do it later on. And that one as well. Have you guys taken the screenshot of it?
No, not yet, sir.
All right, great. Okay, I believe you have.
Yeah.
Right, good. Then on the reflection, they are saying reflect the rectangle in the line of y = 2. Remember when you are describing, you say it's a reflection and then you give the equation, the line of a reflection. So here they have said that we are going to reflect this object in the line of what? In the line of y equals 2, okay? So where is the equation of y equals 2? 2 is here on the y-axis. So you are going to draw your mirror line there, okay? So that is basically it. So the property of a reflected image is that the distance between the mirror line of the image and objects are always the same. That is actually it, okay? So that is actually, yes.
I know this has to do with linear programming now, like the question I want to ask. But then how do you know when you're supposed to draw a straight line and when you're supposed to like draw a dotted line? Because there I forgot.
Okay. Basically, it's on linear programming and we are moving there next.
Yeah.
Just now time, but we are moving there next, okay? So what we do here on a reflection, remember the topic of lines of symmetry. Are we together?
Yes, sir.
Okay. Remember the topic of lines of symmetry and lines of symmetry, and we basically use dotted lines. Okay, the line that we use here is actually dotted. Are we together?
Yes, sir.
Okay, so all you need to know from this side, we are actually using now the dotted line is not going to be bold, but if it's on linear programming, we are going, it's the inequality tells us what to use, but we are moving there.
Okay, thank you, sir.
All right, sure. Okay, so the distance between the image and object is actually the same. Okay, so the distance between the object and the image is the same through the what? The mirror line. Okay, so the mirror line is the line of reflection, and that is now y equals 2. So if you are to reflect this point, you count. So this is 1, 2, 3, 4. Therefore, from there, it's also going to be what? It's as well going to be some 4 steps away from the mirror line. So it's going to be 1, 2, 3, 4. So that point will be right, is going to be right here. Okay, right? So it is basically going to be they are going to be para. Are we together? Okay,
Yes,
so
sir.
if you are to translate that one, not to translate, but actually to reflect that point, is going to be 1, 2, 3, 4. So therefore, on the other side again, it should be what? It should be 4 as well. Okay, 1, 2, 3, 4. So this one is actually it should be there. So you can already see that this whole line, it's fully complete. They are parallel as well. Can you see that? All you need again to do is to sort out the remaining 2. Are we together? The remaining 2. So this one is going to be 1, 2, 3, 4, 5, 6, 7. So 7 there. Okay. So and then you count again from here. 1, 2, 3, 4, 5, 6, 7. So it is actually going to be right here. This point is going to be right here. Okay, and then the next one, we also know that is going to be 7 because these 2 points are actually what? They're actually parallel. Isn't? Okay, so we know that it's going to be 7. So you count 1, 2, 3, 4, 5, 6, 7. So it's going to be there and then you nicely join. Okay, therefore that will be your what? That will be your image after being reflected in the line of y equals what? In the line of y equals 2. Is there anyone with a question? That should be another screenshot you may take. Are you hearing me, guys?
Yes, sir.
All right, you may take a screenshot of that as well because we have done that one and you look at it. Okay. I believe this one you have taken a screenshot already because we have as well looked at that one. Class, I would like us to look at linear programming. The translation of rotation, I want us to do it basically face to face because of the tools that are required to be used. So one needs a compass in order for you to describe and know the center of rotation. One needs to join the corresponding points, and then you find your you bisect the line, okay, the lines and so forth. Are we together?
Yes, sir.
Yes, sir.
Yes, so that one, even if I have to try my best here, I will try, but one really needs a protractor, so it is a practical one, so we will have to look at that in class.
Yes, sir.
All right. Now it's time for me to answer your question, okay? So linear programming, there is a nice question. There is a nice question. So Kakwere, when you look at this, I remember you have asked me, how do you see that here is bold and here is actually dotted line? So there is a difference now when it comes to linear programming. You should be able to know your inequalities. That if you have this, it's actually what? It is a dotted line, okay? This one is a dotted line. But if you do have this inequality, that says less than or equals, it is a solid line. So
Yes.
this one, you should know that you are going to take what? This one, you are going to take this. Okay? You are going to take this one. And when you look at this, it's not there. Oh, what is not there is the dotted one. Are we together?
Yes, sir.
Okay.
Thank you.
All right, sure. All right, now it says that Marina goes to the shop to buy loaves of bread and cakes. One loaf of bread is basically costing 60 cents and one cake costs actually 80 cents. She buys X loaves of bread and Y cakes. Okay. Now the first question says that she must, it is another additional information that she must not spend more than $12. Show that 3x plus 4y is less than or equal 60. Remember, they are saying that Marina goes to the shop to buy what? Some loaves of what? Of bread and cakes, ne? Now a loaf of bread cost what? 60. And a loaf of bread, loaves of bread are actually what? They are represented by X, and the cakes are actually what? Y. Are we together? Now they are saying that she must not spend more than $12. And this question, you need to look at it because this amount is in cents and this is actually what? Dollars. So you need to do your conversion there. In a dollar, there is how many cents?
100.
100.
100. Therefore, you need to multiply this by 100 and then it will be 1,200, okay? 1,200 cents. Therefore, you are going to come up with your own inequality. Remember, she's going to buy what? Some loaves of what? Of bread, and it's X, okay? And one cost what? 60 cents. Therefore, 60x, okay? If it's 1, it will be 60 times 1, which is 60. If it's 2, if the loaves of bread are actually 2, so you are going to multiply 60 times 2 is going to be 120. But when you do not know them, it's just going to be 60 times x plus plus what? Now, the ones for cakes, the ones for cakes cost actually what? 80 cents, ne? 80 cents. So 80 cents, we don't know how many you want, how many of the cakes you want. Now the loaves of cakes, so we do not know of those ones. So it's going to be what? 80 multiplying y, because they are saying for y, for cake is actually y, okay? So if it's one cake, it's just going to be 80 times 1. So this one, how much money is she going to have? She's basically having 1,200. Whatever is she's going to spend, it will not be more than what? It will not be more than what she have. Are we together?
Yes, sir.
It's not going to be more than that, okay? So that is actually what you are going to do. Now, when you look at this, when you are proving, it's actually easy when you come up with your inequality. Now you look at this. What do you have there? They have a 3. How do you turn this 60 into 3?
Divide by 20.
Divide by 20. It means you are going to divide by 20 throughout. What do they have here? They have a 4. How can you make the whole of this to go to 4? How can you make 80 to go to 4?
Divide
When you divide by
You
20.
are going to divide by 20.
Divide by 20.
Therefore, the whole of this is divided by 20, divided by 20, divided by 20. That is all. All you need is to look, what do they have there? What do they have there? Okay, maybe they are having 120 here, and here you have 60. You are going to multiply by 2. But we always divide because we want to work with smaller numbers so that we present them on the Cartesian plane. So this one, 6 divided by 2 definitely is going to be 3x plus what? 8 divided by 2 is going to be 4y. Then this cancels. 120 divided by 2 is definitely what? 60. You end there because they say show. Okay? They said show, and then you just end there, okay? So that one is quite easily done. So when we prove in math, we always write that one when you prove. So it is actually that way. Now another information says that the number of loaves of bread must be greater than all equal to the number of cakes. You should be able to read with understanding, okay? Reads again, it says the number of loaves of bread must be greater than all equal to the number of cakes. Write down an inequality in X and Y to show this information. They have already given you here. They have already provided you here that for loaves of bread is actually what? Represented by X, and cakes is denoted by Y. Are we together? And they are
Yes, sir.
saying the number of loaves of what? Of bread. Bread is actually what? Is X. Must not be greater. It means it should be smaller, isn't
Yes,
it?
sir.
It means it should be smaller, must
So
not be
it
greater.
must be greater.
It must be less. Or they say the number of loaves of bread must be greater. They said yes, it must be what? It must be greater. It means it should be what? It should be more, isn't it?
Mhm.
Yes, sir.
Yes, it means that it should be more, okay? So it should be more than the number of what? Of the loaves of what? Of cakes, ne? So this one is going to be y is less than, because they say greater than or what? Or equal. Therefore, you are going to put this thing here. Are we together?
Yes, sir.
Okay. X. You are done like that. If they just say, if they didn't include this, then this one is not going to be there. Okay. Yeah. So we are going to continue again. We are going to continue again. So it was just a drawing which is next, and I believe we are still on the good note of that. So you will have your little break before moving to your next lesson. And I believe Master Frank would like to say something also from this side.
Yes, sir.
All right.
Good evening, learners. Oh, is it still afternoon? Late
Afternoon.
afternoon. Hi, how are you all?
You're fine.
Good, good. We're like 4 minutes into our break, so we will take a break here. I will share the link for physics, and then the physics lesson will start at 6 o'clock. So those of you that have physics will then just click on the link and then we join that class. And then after the physics lesson, we take another 30-minute break, and then we would have our chemistry. So in physics, Mr. Simba would just do a little bit of recap on electricity, magnetism, and then he'll move over to properties of waves. And then in chemistry, I'll be looking at naming of organic compounds. So we'll try to look at all the different 5 types of families or different types of organic compounds and how we name them. So enjoy your break. We'll see you at 6. Bye.
Thank you.
Bye,
Bye, sir.
sir.
Okay. Bye.
Ini